In the last video, we added a check to our anti-cheat that can detect NoFall, a cheat that allows the cheater to not take fall damage. As another quick demonstration, as you can see, we have NoFall enabled in our client, and when we jump from a high height, we will not take any fall damage. Last video, we detected NoFall by comparing the client ground and server ground states. The client ground is what the player's client tells us, while the server ground is whether we, as the server, calculate the player to be on the ground based on the player's Y position. So the client ground can be a lie because the player could be cheating, but the server ground, which we calculate, is the actual truth. As an example, when a player who is using the NoFall cheat is falling towards the ground, their client could lie and tell us that they're on the ground. However, as the server, we can calculate server ground to be false because their Y position shows that they're in the air. However, hacked clients can have multiple modes for the same cheat, where each mode works in different ways. For example, in the client that I'm using, the NoFall cheat has a normal mode and an anti-cheat mode, where the anti-cheat mode is made specifically to bypass anti-cheats. If we use the normal mode, we can see that the NoFall check we created last video detects it properly. However, if we switch it to anti-cheat mode, then we can see that the check we made last video no longer detects it. This is because while the normal and anti-cheat modes of NoFall both achieve the same end result of allowing its user to not take fall damage, they do so using different methods. As discussed last time, the normal mode of NoFall will lie about its client ground state to the server, which allows it to mitigate fall damage. However, the anti-cheat mode works differently, which is why our anti-cheat cannot yet detect it. In this video, we'll be creating a new NoFall check called NoFall B in order to detect the anti-cheat mode of NoFall. Our check that we created last video will be renamed to NoFall A to avoid confusion. We will also be fixing a false positive in the NoFall check from last video. In Minecraft, a player is supposed to take fall damage when they fall from greater than 3 blocks. Our NoFall B check, which will actually have very simple logic, will simply check for this behavior. If the player falls more than 3 blocks, we'll set an expecting damage variable to true. If more than 500 milliseconds passes without the player taking this fall damage, then we will flag them for cheating. Otherwise, we will not flag them, and either way, at the end, we will set expecting damage back to false. Before we start coding the NoFall B check, there's a problem we must address. When a player takes velocity from things such as knockback or slime blocks, as you can see in this example, it can cause false flags with the NoFall check. As you can see, I don't have NoFall enabled, but I'm still flagged by the anti-cheat here. We'll be updating our PlayerData class with an isVelocityTaken function. If isVelocity is true, then we will cancel the NoFall check to avoid false flagging the player. We'll also add a reduce velocity function to decrement the x, y, and z ticks variables whenever the player isn't taking velocity. In order to update our PlayerData class in real time, we'll add a velocity listener, which is triggered whenever the player takes velocity in-game. When this happens, we will update the PlayerData class with the latest velocity info, including the x ticks, y ticks, and z ticks. Then, we will also call our reduce velocity function whenever the move listener is triggered. As a high-level overview of what the classes in our anti-cheat are doing, the PlayerData class stores important information such as bounding box and velocity states. The move listeners are triggered when the player does things in-game, and it updates the PlayerData information based on what it sees the player doing in the game. Finally, our checks will query the PlayerData information in order to use it in their calculations. We are now ready to start coding the actual NoFall B check. It's quite long, so I've decided to code it beforehand and simply explain what each part is doing. First, we're going to define our minimum fall distance and our damage wait time variables, which is 3 blocks and 500 milliseconds. Next, we're going to create the fall data class, which contains information we need for each player, such as how far they fell, whether they were on the ground last tick, whether we're expecting fall damage from them or not, and also when we've been expecting damage since, which is a long, in milliseconds since 1970. Now we'll create a hash map that assigns UUIDs, which is a unique ID assigned to each Minecraft player, to the player's fall data. Next, we'll create this move listener, which is where the bulk of the logic of the check will occur. We'll get the player that moved and then get the player data and fall data associated with this player. Next, if the player is in creative mode inside a vehicle or has recently taken velocity, then we will basically cancel the check. Next, we will check if the player is going to land on a soft block such as water or slime. If the player is going to land on a soft block, then we do not expect them to take fall damage, so we will also cancel the check. Next, we will check if the player is falling. If delta y is less than 0, meaning the player is going downwards and they're also not on the ground, then we will accumulate the fall distance variable with the delta y. This allows us to track how far the player has fallen. Next, we will check if the player has just landed, meaning that they're on the ground now and that they were not on the ground last tick. If they just landed and they fell more than 3 blocks, then we will set expecting damage to true, and then also set expecting damage sense to the current time. Finally, if we are expecting damage and more than 500 milliseconds has passed since we were expecting damage, then we will flag the player for using NoFall. To handle the case where a player is not cheating and takes fall damage normally, we will use this entity damage event listener. If a player takes damage and the cause of their damage is falling, then we will set their expecting damage variable to false because they took fall damage properly, and we will also set their fall distance back to 0. We are now ready to playtest our NoFall B check. As you can see, I have the anti-cheat mode of NoFall enabled, which is the one that could bypass our NoFall A check from last video. If I jump, you can see that I will not take fall damage, and after 500 milliseconds passes, I will flag NoFall B, as you can see in the chat. We will now fix a false positive in the NoFall A check from last video, which would occur when a player jumps up onto a block and then immediately walks backwards. As you can see, I don't have any cheats enabled, but I'm still flagging the NoFall A check every time I do this. We can actually fix this by modifying one line of code, by changing the OR condition here to an AND condition. Now, even if the player is not near the ground or last server ground is false, the buffer will still have to be more than 1 in order for the flag to occur. Previously, if the player wasn't near the ground, then the buffer would be ignored, which was causing the false positive. By reintroducing the buffer, we have solved this false positive. You can see that this false flag is now gone, and we can do our previous behavior without triggering the check. The NoFall A check still flags real cheaters correctly though, as you can see. As an interesting side remark, we can see that my NoFall A check actually detects fly in certain situations. If we fly like this, then we can see the NoFall A check being flagged in the chat. However, if we jump and fall first before we start flying, we can see NoFall A is no longer flagging. I'll explain why in the README of my GitHub repository, so go check that out if you're interested. Thank you so much for watching. In the next video, we'll be creating a check for speed, also known as bunny hopping or bee hopping. If you enjoyed the video, please like and subscribe. It would really mean a lot to me.